We're going to kind of continue on. We're going to talk about solving basic exponential equations using logarithms. So the property that we're going to focus on here, let me start a different way. We want to solve this 3x. We learned a property that said if I had log something to a power, I could rewrite that side and turn that power into multiplication in front. We just practiced with that. We want to solve for this x, and this x is a power. So we're going to go x. So we're going to put log on that side. So we're going to write this thing as log 3x. Now, because this is an equation, because it's got an equal sign, whatever I did one side to keep it balanced, I have to do to the other. We know that works because we've used this to solve. If we get single logs on either side, they essentially cancel, except the stuff inside the parentheses equal. But what this allows me to do, now that I have this log here, it allows me to write this as a multiplication in front. X times the log of 3 equals the log of 8. And from here, log of 3 is the number. We can plug this in our calculator. We can find an answer for it. So in fact, let's do that real fast. Bring up my calculator real quick. Okay, so let's clear out what we had done before. And we're going to go, we're going to hit the log button, go log of 3, hit enter, see it's just a number. And what we're focusing on here is that it's just a number and it's multiplying that x. That means to get rid of it, I can divide it on this side because my goal is to get x by itself. And that will cause that part to cancel because same thing on top and the bottom always cancels. But what I do to one side, I have to do to the other. So we're going to get an exact answer of log 8 divided by log of 3. And we're always going to write them both ways. This is the exact answer for this. And then we're going to get a rounded answer. And our rounded answer, we're going to go log 3. I've already got it in there, so I'm going to hit divide. And we're going to go log of 8. If she close those parentheses this time, we get 0.528. So here we're going to say this is about 0.528. This is our rounded, and we're going to get used to writing them both ways. And that's it. It's that simple. It's just a last step of algebra that we need to finish solving these. Now, some of these things can get a little bit more complicated. So if we look at this one, this is different because we've got an x minus 3 up here on top. But we're still going to take the same steps to tackle this. We're going to write log on this side so we can get that exponent down and make that exponent a multiplication. So this is log of log of the left side, log of the right side, because this allows me to go x minus 3 times the log of 3. This is log of 12 still. And there's two ways we can tackle this now. We could distribute this, or we could just do 2 divisions to get it over there. I like 2 divisions. I'm going to divide the log 3 to the other side. So we're going to get x minus 3 equals the log of 12 divided by the log of 3. It's a number. We can find the answer. Now to finish this solving, we're going to add that. So that means we're going to have this expression, the log of 12 divided by the log of 3. Once we find that answer, we're going to add 3 to it. So this is our exact answer. We're going to come back in here and plug this into our calculator. So we're going to go log of 12 divided by log of 3. Close those parentheses after you plug in log. And now we're going to add 3 to that. And that means our about answer is 5.26. I'm good with that. So this is about equal to 5.26. That is our rounded. And those are the answers that we're looking for. All right. What else we got going on here? So, same process. Only thing is we've got some extra junk in here we need to get rid of. So, to get rid of these things, what we need to do is we need to isolate this. That needs to become, when we get down here before we can apply log, we need to have that equals something. We got to figure out what that something is. So we've got to get rid of these two parts, meaning this plus 20 and this times 11 need to go to the other side. So the first step of this would be to minus that 20. When we minus that 20, we get 16. And we're going to divide that 11. When we divide that 11, we're going to get 16 over 11. Since we're going to maintain our accuracy, we're not going to round that. Now this is where we want to apply log. Now actually here, we want to apply natural log because we have base E. When we apply natural log to this, it's going to do something special for us. It's going to make our math easier. So that's going to make that turn into a multiplication. It's not going to change this side. Now what we need to discover here is plug in natural log of E and see what happens. We've done this once before. So natural log, you've got to hit second key here to get this E in. And what we see here is that's 1. And that's where this becomes a little bit easier. This right here equals 1. So because that equals 1, this is really 5x times 1. It doesn't do anything. And we're going to talk about why that's equal to 1. But let's actually finish the problem first. So this part doesn't matter now. So to get x by itself, we'll divide that 5 to the other side. We'll plug that in. So here's our exact. And now we're going to find our rounded. So natural log of 16 divided by 11. Apologize, trying to test something out. So we get 16 divided by 11 in there, close those parentheses, hit enter, then I'm going to divide it by 5. I get 0.075. So we're going to get 0.0, erase that stray mark. So we're going to get 0.075. That right there, folks, that is our rounded. I do want to talk about this natural log of E and why it is equal to 1. So what we need to remember here is that natural log is really log base E. Just like we did on the other slide, the reason this is 1 is because now what we're doing is we're matching the base of the exponent base of the power. So base of the exponent, base of the log. And when that happens, those things will cancel. So when we do this, this essentially cancels this, and that's why it's 1. Meaning that if we were to do the natural log of E to the 3.6, we're going to get 3.6. Whatever the power is here is always going to be what we get. All right, I think we got one more, then I'll let you be. Okay, so this one is a little bit different. But this one works very similar to ones we've solved before. You got to remember, this just means log base E. And if we have the log of 5x equals the log of x plus 10, what we would do is we would say those don't matter and just go 5x equals x plus 10, and we would solve it from there. I'm not going to finish solving that one, but the same premise happens here. These things don't matter in this expression because there's only one of them on either side and everything else is trapped inside what we would take natural log of. So we get e 3 minus 4x equals 6. So now we're going to get 3 minus 4x times natural log of e when we put natural log on both sides. No, that doesn't matter. If you just saw that was my dog. 3 minus 4x equals the natural log of 6. So now we're going to minus that 3 to the other side. And then divide that -4. And bam, there's our exact, because we got x by itself. Plug this in and we'll find our rounded answer. So we're going to go the natural log of 6. And we're going to minus 3 from that thing. Then we're going to divide it by -4. And it helps if I hit the right keys. We get 0.302. So 0.302. This is our rounded. And one bam, there it is. Those are our answers that we're heading for. This one's a little tough. We might come back to that one. But this is a factoring problem. We'll come back. We'll do that one special in its own video. All right, here, it's only log on one side. This is different than the last one we did. Since this one only has log on one side, anytime you see that happen, convert this thing to exponential form. So that means this is 4 to the power of 3 equals x plus 10. And all of a sudden it becomes super easy to get x by itself. 4 to the third minus 10. And then we just plug that in. There is no rounded for this one, so we're going to get an exact answer because there's no log involved in the answer at all. We got rid of it. And I'm going to write on the other side. So we go 4 to the third. So 4 to the power of 3. And we're going to minus 10 from that thing. 1, so let's try to get minus 9, so 54. So that means we get an answer of 54. That's it. This is our rounded and exact. And one ball of wax. I like it. I like it a lot. Hey, that one didn't space right, but this is very much the same problem we just did on the other slide. Only problem is there's some extra stuff right in here that we need to get rid of. And to get rid of those things, what do we need to do? We need to minus that 8, so it's going to turn into 4 log 3x, and 28 minus 8 is 20. We're going to divide the 4. Log of 3x, that's 5. This has a base of 10. There's only log on one side, just like the last one, so that converts to 10 to the 5th equals 3x. So a little bit of manipulation here. 10 to the 5th divided by 3. So let's see what that gives us, see if we can write the exact answer. So let's shift over to our calculator. It was, what was it, 10 to the 5th? I believe it was. That should work a little better. Pop it over here. So 10 to the 5th. And we're going to divide that bad boy by 3. And since we see 0.3 repeating, we know that's a third. So that was, I clicked it away and I didn't mean to, 33,300. So we get 33,333 and a third. There's our answer. That would be the book assignment. We're going to still work out a book while we're out of class, guys. Okay? Yeah, make sure you come to office hours. I'll answer a bunch of these questions if we need to. I can always write them up on the slides. We can work them together. Okay? Let's go back to that last one real fast, just before we log off and post this video. All right, so here, this is weird. This is a factoring problem. Because what happens, what you're supposed to see here is this is e to the x squared minus e to the x minus 6. Because the way powers work. Meaning that this is, let's put an a in here, this is a squared minus a minus 6 equals 0. You know, factor this thing like a quadratic. So we look for the factor 6 to have a difference of 1. We get 3 minus 2. So that means this should factor into a minus 2, sorry, a minus 3. We'll start over there. That's a minus 3, a plus 2 to give us that negative 1. The only thing I remember is we substituted here. So we could see this a little bit differently. E to the x is where we replaced with a. So to actually write our final answer so we can solve this, we need to put that e to the x back in. So when we go through and we do this, what we factor this into is e to the x minus 3 e to the x plus 2. Now remember, we go to solve quadratics. If we had solved this thing like a quadratic and we had a minus 3 and a plus 2, and they're both equal to 0, we're going to solve each one of these equal to 0. We're going to do the same thing with this e to the x. This gives me one expression to solve when it's set equal to 0. And I switched the sign on us. Let's fix that. So we're going to add that to the other side. We get 3. We've got to take natural log times the natural log of e equals the natural log of 3. We know this doesn't matter. So that's x equals the natural log of 3. That is one solution. We do the same thing over here. E to the x plus 2 equals 0. Move 2 over. We're going to get negative 2 e to the x, and we go to solve this one same way. And we know this doesn't count. So we're getting these are exact answers. All right, these are both exact. Let's find the rounded for both of these. So let's plug them in and see what happens. So we're going to see what is the natural log of 3. Natural log of 3 is 1.10. Let's go with 1.10. So this is 1.10. That's its rounded. A little messy here, but you guys are used to that. You've been in my classroom before. So x is about equal to, let's plug this one and see what happens, because this one's different. So x negative 2, we hit enter, and what do we get? Oh no. In real mode, all calculations must result in real numbers, non-real answers, because there's no answer. We cannot plug in negatives into logs. We have to remember that. So this is actually not part of an answer set. This is the only answer set that'll work. So what we have to remember here is we cannot plug negative or 0 into log or natural log. And we always got to check that thing when we go and get our answers.